Now, these are just individual storms, the pulse severe and a single cell. We start to get a little bit more organized where now we're talking about a cluster. So there's more than one storm cell. There may be 3 or 4 of them lined up out there. This is the most common type of thunderstorm, and this is what kind of activity we had today across the area. So it's not just one individual cell, it's multiple storms. They're all kind of merged together. They're all in a different phase of the life cycle. Like I showed you earlier, the beginning stage, or the towering cumulus stage, the mature stage, the dissipating stage. So that's what we're looking at here in a single picture, where all 3 stages are coexisting at the same time. So this end, the right side, is not the severe potential. The middle section is the severe potential. The one on the left is what we'll be having to worry about in 10 or 15 minutes. So these are very interesting to follow. Some days are more organized and it's easy to follow and issue warnings, and other days it's not. So multi-cell cluster storms, this is the second part of it. These typically last for 20 minutes, individual cells I should say, but the physical storm itself may last for several hours, like what we had today across southwest Louisiana over here as well, where the overall storm would last for several hours, but the individual cell would only last for 20 minutes or so, producing heavy rainfall. There's always potential for winds. I'm not sure why I've got 80 miles an hour, because the reality, the wind speeds can be even higher than that. Hail sizes would be varied depending on the time of year. Golf ball size is a typical number that I would throw out for our area in the springtime, but like I showed you earlier, we have had hail larger than that. The multi-cell cluster is the beginning of where there is potential sometimes for a weak tornado to occur near that updraft, downdraft interface. And so this is not the most likely scenario for tornadoes, but we do once in a blue moon get a tornado dropping out of these multi-cell cluster type storms. Now a little bit more organized from the cluster is now we're talking about lines, multi-cell line storms. And so it's also known as a squall line. And we're probably all familiar seeing this on TV or on the phones and internet when it's basically a long line of storms. If this picture here, if the storm is moving from, let's just say, left to right, you're focusing on this activity as it's heading into an area. The well-developed gust front and leading edge. So like in this picture here, this little thin line of towering cumulus out in front of it got blown out in front of the main storm line. So this area between the thunderstorms and this gust front is where there may have been some gusty winds. It may be like the 20 to 30 mile wind gusts out in front before the rain even gets to your house. But the heaviest rain and hail doesn't occur out there. It's happening obviously in the big band of storms behind it. And so this is kind of a radar picture of what it might look like. It actually evolves. This multi-cell line storm, it may start out as a pulse storm. It turn into a multi-cell storm, and eventually will bow out into some sort of a line. So where are the features for the different events? Typically the center feature is going to be where the potential for the highest winds and the hail is going to be located. But as it starts to bow out and one end gets a little curled to it, these ends with the curls potentially could be where tornadoes would develop. So like I said, not always, very often, but they do occasionally get tornadoes in the ends of where the lines are located. The classic tornado storm out there is the supercell storm, and there's a couple of variations to it that we'll be talking about. These are relatively rare events down in this part of the country, but when they do occur, it poses a high life and property. And the reality is these supercell storms do produce tornadoes, but even when they don't produce tornadoes, odds are they're producing large hail and damaging winds in the area irregardless. So we're likely going to be issuing tornado warnings for these events. And even if a tornado doesn't occur, more than likely we're going to see either hail or damaging winds anyhow. So it's good to be warning out on these kind of events. So the features of what it would typically look like, it can produce giant hail, strong winds, the strong and violent tornadoes. A lot of times down here locally, the tornado is wrapped in the rain shield. And that's our biggest problem from the perspective of spotters and weather observers. This is why we don't want people to jump in a car and go chasing after this stuff, because it's not going to be super visible to see a tornado when it's wrapped in this rain in the background there. So from the perspective of the radar feature, this is what it looks like on the right, a big blob of red, and it kind of wraps around, kind of like if you're measuring, making a letter C. That's going to be the indicator of where the tornado is developing, where all this stuff is kind of wrapping itself around. So on the picture on the right, What we're looking at is showing an area of blue, moderate, heavy rain and hail. Over here on the right side, the red blob is where the heavy rain is for sure. That's also the area where the hail is probably occurring also. I know back in the day, people used to tell me all the time that you always get hail before the tornadoes hit. And that's not, a hard, fast rule, but the reason why people would say that, because in your classic supercell storms, this rain-wrapped rain on the leading edge before the tornado gets to you would typically be producing hailstones out in front of it before the tornado hits you. So here's an example, once again, a little bit better diagram. You can see the tornado indicated by T here, an updraft region, and then two different downdraft regions, one up here to the northeast, and then there's one down here to the bottom, I'd call it the south-southwest. And so these downdraft regions, areas where there can be high winds, besides the spot of the tornado itself. And so here's an example of the rear flank downdraft. You can see the areas here indicated by the blue arrows showing that rear flank downdraft. So the rain indicated by that dark shade down to the right side of the picture here. This is the updraft region out in front of it, indicated by the red line, and the downdraft right adjacent to it. So the downdraft region, this is where we talk about the damaging winds a lot of times. And this is what we're talking about. A lot of times people will get confused seeing these little spotty clouds out here, thinking they're looking at a funnel cloud, thinking they're looking at a tornado, when it's actually just debris clouds associated with a rear flank downdraft. So just a couple different examples of what we're looking at here. Here's your main storm tower, the main updraft region indicated by this cloud to the right. And a lot of times there'll be enough, this is of course just dependent on the angle of the sun and whatnot, so it looks like there's a big bright light shining through it, but that also indicates the area of a downdraft where there's a big hole out there where there's no clouds up there. So the HP supercell, the high precipitation supercell, is the typical supercell event that we're going to get down here in South Louisiana. And this is where we talked about earlier that the tornado is wrapped with rain on both sides of it. So here in the picture, you can see T indicating the tornado. There's rain on both sides of it, where it's very difficult to see the tornado itself while it's on the ground. So the picture on the left, you got this good viewing of the tornado. Tornado would be indicated by the little green circle here. Great viewing of a tornado if you're on the southeast side of the storm. Not so much over here on the right side because there's more rain wrapped around it. So here's an example showing the tornado itself wrapped with rain all around it. Very difficult to distinguish a tornado from the rain shaft in general associated with it. And there's just different examples of supercells on here. You just, go picture after picture. So the visual aspects of severe thunderstorms we talked about before. This is just an aerial shot, but the overshooting top of a cloud, thunderstorm cloud is anvil. It's usually flat, relatively flat. You see the little bubble popping on the top of it. That's the overshooting top. That indicates severe weather is occurring down below it. So depending, this is an airplane view. This is obviously probably like a spatial view. Different angles of what that would look like. The main storm tower, if it's got rapid upward motion, that would be an indicator of severe weather. We've talked about this in the first class as well. And so, once again, a lot of this is the review part here for the wall clouds, and I'm not going to go into all of it. But here's a time series of a wall cloud, that originates, very interesting feature, how it gets itself organized, and then it kind of dissipates and falls apart again at the end. All right, on the shelf cloud, the shelf cloud we've talked about before. If there is no tornado out there, the shelf cloud, where that rear flank downdraft is located, you have a lot of funny looking clouds dangling from the backside of it, and so that's what these things look like. And this goes back to what we talked about in the first presentation about standing outside, which way is the wind blowing, if it's blowing in your face or they're blowing from you towards that tornado or towards the cloud. If it's blowing in your face, then you're looking at the shelf cloud. So, different examples of the shelf clouds and typically what it would look like from the perspective of the overall wind environment. The wind that you're going to feel is these little black arrows, the wind blowing in your face. Just different examples of what it would look like. And we talked about it before, the lookalikes. I'm going to skip across the lookalikes because we've kind of talked about this before as well.